Hi everybody, today is going to be our last day talking about quadratic functions. And to wrap it up, we are going to compare the three different kinds of functions that we have talked about this year. We're going to look at linear functions, exponential functions, and quadratic functions and compare the three by looking at their shape on the graph, their equations, and the way that they look in a table. Let's start with linear functions. Linear functions are our easiest function. It's what we start every year with, and we've seen them for a couple of years now. Linear functions always form a straight line. That's why the word line is inside of linear. Our main equation for a linear function is y equals mx plus b, where m is our slope or rate of change, and b is our y-intercept or starting value. Linear functions can be vertical, they can be horizontal, they can be diagonal in any direction, as long as they form a completely straight line. On a table, a linear function is going to follow a specific pattern. In this case, we have our x values going up by 1 and our y values are going down by 4 every time. 16 minus 4 is 12, minus 4 is 8, minus 4 is 4, minus 4 is 0, and so on and so forth. For a linear function, we can tell from a table that it's linear if it has what is called a common difference. A common difference is when we can add or subtract the same number every single time down the y part of our table to get the next number. In this case, we're subtracting 4 every time. If we were adding and subtracting the same number, it would be a common difference, and it would be a linear function. Exponential functions work really similarly. Here, instead of a straight line, an exponential function always forms a curved line, and the function that represents an exponential function is f of x equals a times b to the x. Here we have an exponential function. Our x values go up by 1 every single time, but our y values follow a slightly different pattern. They go 1/9, 1/3, 3, 6, 12, 24. Here, as we travel along our y values, we are multiplying every time by 3. While for linear functions, we were adding and subtracting the same thing every time and said we had a common difference. For exponential functions, we are going to multiply or divide every time, which gives us a common ratio. There should not be an "in" at the end of that word. That's what gives us what's called a common ratio. Finally, we're going to move on to quadratic functions, which were the last of our three major kinds of functions that we learned about this year. Quadratic functions always form a parabola. A parabola is a U shape, whether it's facing up or facing down. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. And the way that quadratic functions work in a table is going to be a little bit different. Here, we can't add the same thing every single time, and we also can't multiply the same thing every single time. 0 times nothing will equal 3, and we're definitely not adding 3 every single time to move up this y column. But if we look at the addition, 0 plus 3 is 3, 3 plus 7 is 10, 10 plus 11 is 21, 21 plus 15 is 36. What we discover is that while the first differences do not all match, if we find the differences between the differences, this is called the second difference, they will all match. So while 3 and 7 don't match, the difference between 3 and 7 is 4. While 7 and 11 don't match, the difference between 7 and 11 is 4, and so on and so forth. We can know that a table is a quadratic function if they have a common second difference. So as a reminder, a first difference is like a linear function where we add or subtract the same thing every single time. A second difference is going to be in a quadratic function, where though don't add the same thing every single time, if we look at the differences of the things we add, we realize that there is a pattern between them. Hope this video was helpful. Feel free to leave any comments, and I'm looking forward to our next lesson.